All right, as we continue on in this chapter dealing with various types of equations, we've looked at quadratic equations, and we talked about the discriminant, remember, and we said that if the discriminant is negative, our answers will be imaginary. And I said eventually we're going to talk about imaginary numbers, and the time has come. For years now, square roots of negatives, you just can't do it, it's imaginary, we'll talk about it later. Square root of negative, that's imaginary, we're going to talk about it later. Well, later has come. Today you've been looking forward to, you've been bothered for so long, Audrey, like, I just want to know, and now you get to know. I want you to consider something real quick. You don't have to write anything down yet, I'll tell you when it's time. If I were to square a 2, of course, class, we know I would get a 4. And if I were to square a negative 2, we know I would get a 4. So therefore, we would say that when I take the square root of 4, there are actually 2 square roots, 2 things that when squared give 4, both positive and negative 2. Which is why we say, well, take the square root of negative 4, what do we get? Nothing, because nothing squared can equal a negative 4, right? And so for years, it was just believed that there's no such thing as the square root of a negative. The problem is, scientists, as they began working with different things, discovered you have to be able to take the square roots of negatives. But you can't take the square root of negatives. They decided to make it happen. So write this statement in your notes. Square roots of negative numbers are imaginary. These are what we call real numbers. But square roots of negatives are called imaginary numbers. And a lot of mathematicians these days really say it's unfortunate that the word imaginary was chosen, because to many people, imaginary is like, you know, Brandon's imaginary friends. When you have the imaginary friends, it really means you have no friends. Imaginary numbers. They are not numbers. If they're imaginary, they do not exist, and that's not true. They do exist, and they have useful purposes in science especially. It's just that was chosen initially, and almost, you know, some people say, oh, gee, it's a shame we didn't pick some other term like, I don't know, inverse numbers or something like that. But here's the key to working with imaginary numbers. We're going to take the most basic square root of a negative. Well, you can't get more basic than negative 1. So we're going to take the square root of negative 1, and we're going to represent it algebraically with the letter I. Since I stands for imaginary, and imaginary had been the title previously chosen for these. And this key fact, that a square root of a negative 1 equals I, or could be represented I, is going to enable us to do quite a bit with imaginary numbers after all. Some things we need to talk about first, though, before we get into how we'll use I, are what we call fundamental powers of I. Fundamental powers of I, because we're going to come across these quite often. The first fundamental power of I is I to the first. Well, we know anything to the first power is itself. So I to the first just equals I. You probably could have guessed that. I squared. Well, keep in mind, I is simply a representation class for the square root of negative 1. Class, what does I represent? So I squared literally means the square root of negative 1 squared. And you know when we square a square root, we get the radicand. So if we square the square root of negative 1, I will get, so an I squared equals negative 1. An imaginary value squared produces a negative real rational value. All right, what about I cubed? Well, we know that I cubed simply means I squared times I, right? And I squared is negative 1, and I, of course, is just I. So negative 1 times I gives negative I. If you cube an I, you get negative I. Finally, I to the fourth. Well, I to the fourth, that would be I squared squared, or I squared times I squared. But I squared, class, is negative 1. Okay, that's pretty weak. Class, I squared is negative 1. So if we have I squared times I squared, that's negative 1 times negative 1. That gives positive 1. Put a star next to that as well. I to the fourth equals positive 1. Fundamental refers to basic, can't get simpler than that. These are the 4 fundamental powers of I, because any bigger powers of I could be represented by taking away 4th powers of I. If you'll write that in your notes, all higher powers eliminate or divide away 4ths. All higher powers eliminate or divide away 4ths. If you have a higher power of I than I to the 4th, divide away or eliminate 4th powers. So for instance, I to the 18th is not a fundamental power because I could write it in terms of one of these or several of these. I could say this is I to the 4th times 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 I squared, correct? And every time we see an I to the 4th class, that's just equal to 1. So this is 1 times 1 times 1 times 1 times negative 1, which is what? Negative 1. So I to the 18th essentially becomes equivalent to I squared, which is negative 1. Bigger powers become these. Now here's the practical way to think of this. I to the 18th. What is the biggest multiple of 4 in 18? 16. Knock out 16 of those i's. That's literally what we did right here. We knocked out 16 i's. How many i's we got left? And that equals negative 1. And we're done. If I had the square root of negative 1 to the 11th power. Well, what is the square root of negative 1 again, class? I. So really this is just saying I to the 11th. All right, what is the biggest multiple of 4 that's in 11? 8. So if I took 8 of these i's, that would be a couple of 4's. And every 4 i's equals 1. We'll save the glasses jokes. I noticed she took hers off in anticipation. All right, so Maddie left hers on. All right, so here we go, Maddie. But we take away all the 4 i's. Well, there's 2 sets of 4 i's in there. 2 sets of 4. Okay, counting myself 3. But there's 2 sets of 4 i's. If I take away the 2 sets of 4 i's, how many i's are left? 3. So really, I to the 11th, by taking away 4th powers, which are 1's anyway, 1 times 1, we're left with 3 i's. And I cubed, class, equals negative I. It's on the board. You can read it. So any higher power of I becomes one of these. So as long as you have these memorized and you know how to knock 4's out of stuff, you're good. What if I had an I to the 23rd? Well, what's the biggest 4 that's in 23? 20. Knock out 20 of the i's. How many i's are left? 3. And I cubed is? Negative I, just like it was in the last problem. What if I had a square root of negative 1 to the 20th? Well, again, square root of negative 1, class, means I. Okay, what is the square root of negative 1, class? I. What is I? Square root of negative 1. Not what am I? What is I? What is I? I is the square root of negative 1. I really is. All right? Square root of negative 1 is I. The grammar sounds horrible, but anyway. So, this is really I to the 20th. What's the biggest 4 in 20? 20. It is a 4. So this literally would be I to the 4th, 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 which is 1, 1, 1, 1, 1, which is 1. If something is a multiple of 4, it has to be 1. If it's not a multiple of 4, knock out the biggest multiple of 4, and whatever you left with is going to be one of these. It's either I, negative 1, or negative I. Make sense? Do we see how to knock out 4 i's? Questions on this? Yes, sir?
Can you demonstrate knocking down 4 i's?
Yeah, can you borrow your glasses? All right, so page 104 in your textbooks. Page 104 in your textbooks. I want you to do 5 through 12. And knock out 4 i's out of each of these. Whatever you're left with, it's going to be one of the fundamental powers of I. Write your answer. This lesson would be so much more fun to teach if I didn't wear glasses, I tell you.
We're doing 1 through 12? No, 5. That's what I was thinking.
his life, Brandon's been taught, you can't hit a guy with glasses, don't hit a guy with glasses. And now all of a sudden it's like, knock out the 4 eyes. I've been told the correct grammar is I am. Now it's I is square root of negative 1 I. So everything he's ever learned turned upside down. He's a very confused individual over there. He's that piece of the sticker as consolation.
Contacts, nose.
Nice. I can't do that. I can't do stuff touching my eye.
It's painful.
Is it?
For me, not for Audrey.
Audrey's cool with contacts. How many wear contacts in here? So really the only people with good eyesight are Kendall, Brandon, and Abby?
I typically have glasses, I just don't really need them.
I have a pleasure.
You don't? How many fingers am I holding up?
4.
I'm holding them down. You do need glasses.
Hold up.
All right, anyway.
That's a good one.
Heaven's like, I need glasses
Yeah.
too. All right, anyway, let's take a look at these together. Number 5, I to the 4th. What does that equal, Abby?
1.
1. I to the 7th, Brandon.
Negative I.
Knock out 4 i's, gives I cubed, becomes negative I. Good. Number 7, I to the 15th, Maddie.
I don't know, maybe take out 8. Maybe.
Well, there's actually, you can take more than 8. There's a bigger 4 inside 12. I mean, inside 15.
Yeah, 12.
12, yeah. So if we take out 12 i's, that leaves us with how many i's? Right, those are 3 i's, right? I cubed, so that becomes negative I. That should have been our answer. What about I to the 33rd, Audrey?
Negative 1.
What's the biggest 4 in 33?
32.
And if you knock out 32 i's, how many i's are left? Just 1, so I. Just I. I is all that's left. All right. Like Luke Skywalker, you know. No, there's another. All right, number 9. Genesis. What's the biggest 4 in 42? 40. Knock out those 40 i's. How many i's are left? 2, and I squared is? Negative 1. Number 10. What do we get for our answer, Kendall? I. What about number 11, Michael?
I is the answer.
I is the answer to all of life's problems. And number 12, what do we get for that one? Let's go back to Audrey.
Negative I.
Maddie?
Negative 1.
Should be negative 1. Our biggest 4 is a 52. That wasn't on our 4 times tables, right? We went as far as 4 times 12. So maybe you're like, well, I know 48. So you knock out 48 from the I to the 54. It gives you I to the 6. Like, there's still 4 more in there. Knock those out too. Now we're down to an I squared, which is negative 1. That makes sense? All right, so, and even, Maddie, on yours, you have the I to the 15th. So like, well, I know there's an 8. Well, you know what? That's okay. Take out what you know. I know there's 8. That leaves with 7 i's. Oh, I can take out another 4. So it's okay if it takes a couple steps. And then there's our negative I there. But the important thing is, class, that you memorize these fundamental powers of I. If you've got them memorized, those are easy. Because on quizzes and tests, you can't, no cheat sheets, right? So, anyway. All right, so how do we actually work with the imaginary numbers? Now that we know how these fundamental powers work, how do we actually work with imaginary numbers? Well, again, we said imaginary numbers are square roots of negatives. Square roots of negatives are imaginary. So the square root of negative 9 is going to be an imaginary number. How do we work with this? Well, you can't take the square root of the negative initially. So we can factor this into the square root of a negative 1 times the 9. And you're going to use the negative 1 as the leading factor. But the square root of negative 1, class, is I. So really, when we see the square root of negative 9, it becomes I times the square root of 9. It's as if the negative could just be pulled out in the form of the 9. And then the square root of 9, of course, is 3. So we just get 3i. If it were in an equation and I put the square root symbol there, I'd say positive negative 3i. If I had the square root of a negative 12, well, obviously we need to factor this, and the first factor needs to take care of the negative. So just negative 1. I could further factor the rest of the 12 into times 3. The square root of negative 1 becomes I. The square root of 4 becomes, and the square root of 3? Square root of 3. And notice the order, by the way. The numerical coefficient first. I actually would run in a set of other variables alphabetized. So if there were like an A and an X in the same problem, it'd go between the A and the X. It gets alphabetized. And then the radical at the end. Does that make sense? So really then, when it comes to working with square roots of negatives, again, if it worked for the negative, you say 2 square root of 3. There happens to be a negative in the radical, in the square root, so we just pull out an I. If you write that statement in your notes, the key to working with imaginary numbers is to first, underline the word first, pull out your I. The key to working with them, I said it with a straight face this time. The key to working with imaginary numbers is to first, underline first, pull out your I. Not put out your eye or pluck out your eye, though the Bible does say if it offends you, pluck it out, but pull out your eye. Well, Mr. Desky said I should pull out my eye. Only if you're working with imaginary numbers. The key to working with imaginary numbers is to first pull out your eye. So if I have the square root of negative 32, for instance, well, the first thing I'm going to do, I see square root of negative, and we know that always, class, the square root of a negative is imaginary. And so to work with imaginary numbers or square roots of negatives, the first thing I do, class, pull out your I. I times the square root of 32. Now, we can work with it like we always used to. So radicals are back again, but now we just pull out i's first. And your own i's. Anyway, and so we factor the 32 into 16. And then we, out of the square root of 16, we get 4. So our answer will be 4i times the square root of 2. Make sense? Working with radicals like we used to, we just have to pull out our I first. So, if you have the square root of negative 49 at your seats, square root of negative 16, square root of negative 144, square root of negative 24, cube root of negative 27 at your seats. Simplify those 5 radicals. And anytime you got the square root of a negative, pull out your I.
What about the cube root of a negative? Same thing?
Well, you can take the cube root of a negative, can't you? Odd roots of negatives are negative. It's just the even root of a negative you can't take. Even roots, or square roots specifically, those are the ones that are imaginary. So I see a square root of a negative, class. What do? Pull out your I. Now it's the square root of 49. What do I get?
7.
So 7i. Here, what's the first thing I've got to do? Audrey? Pull out your I. And then I take the square root of 16 to get?
4.
So my answer? 4i. Here, square root of negative 144. What do I got to do first? Maddie? Then I've just got the square root of? Which is? So my answer? 12i. Here, see a square root of a negative. What's the first thing I do, Genesis? Pull out your I. Then I got to take the square root of? Ooh, if it were 25, it'd be 5i. But what do I do with the 24? So I pull out and I leave the, and so I'm going to write my answer as, read it. Perfect. 2i times the square root of 6. Here I see a cube root of a negative. Do I pull out the I, class? No, it's not an imaginary number. Imaginary numbers are square roots, or in a way you could say even roots. We're going to get to that later. But square roots of negatives. This isn't a square root of a negative. I don't pull out the I. What's the cube root of negative 27?
Negative 3.
Negative 3, because if you cube a negative 3, you get negative 27. So don't pull out the I on the odd roots. Only on the square roots do we pull out the I. Questions on this? Feel like we got a handle on this? Seem easy enough? All right, so let's talk about adding imaginary numbers. To add imaginary numbers. Step number 1. pull out your eye. Step number 1, pull out your eye. Step number 2, combine like terms and or similar radicals. Combine like terms and or similar radicals. Pull out I. I guess you could argue you have to take roots or reduce. So take roots or reduce. I guess I didn't write that down because to me it's, anyway. And number 3, combine like terms and similar radicals. Gotta make my notes more detailed. Colts game last night. And just put a little arrow, like leave it up. Combine like terms or similar radicals. So for instance, if I have the square root of negative 25 plus the square root of negative 9 minus the square root of negative 4. I see square roots of negatives. What's the first thing I gotta do, Kendall?
Pull out negative. Or take out your eye.
Now take out your eye.
Oh, you pull it out.
Rip out, no, pull out your eye. So when I pull out the I, it becomes a 25, and the square root of 25, so this just becomes 5i. And then the square root of negative 9 becomes, I'm sorry?
3. Negative 3. No.
Well, what happens with the negative? We pull it out, it becomes
I.
and then the square root of 9 is
3.
So it's a 3i. Right? What about the square root of negative 4, Kendall?
2i.
2i, but it's a minus 2i this time. Make sense? All right, now, these are all like terms because their literal coefficients are the same. The I happens to have a very specific meaning, but it is still a variable, and these are still like terms, so we combine 5i plus 3i minus 2i plus 6i. Easy enough? Write this one down. The square root of negative 16 plus the square root of 36 minus the square root of negative 64. Michael, what's the square root of negative 16?
4i.
What'd you call me?
4i.
See me after class. All right, what do we get for the square root of 36? 6. But no I. What do we get for the square root of negative 64?
8i.
So we'll have a negative or minus 8i. Now here, 2 of these terms are like to each other. The other isn't. This 6 is not an imaginary number. It's a real number. These 2 are imaginary. They will combine 4i, negative 8i, Brandon.
Negative 4i.
Negative 4i, and we'll write the real value before the imaginary. Real, then imaginary. This is something we call a complex number. We're going to be looking at those more in next week, in the days ahead. But a real number coupled with an imaginary value forms what we call a complex number. We'll always put the real before the imaginary. Write this down. The square root of negative 24 plus 3 times the square root of negative 96. I see square roots and negatives. What do I got to do first, Abby?
Pull out the eye.
Pull out your I. And when I pull out the I just have to, I'm left with the 24 now. And I factor the 24 into,
4 and 6.
and that gives me,
2i times square root of 6.
and since this came out to a square root of 6, I'm thinking maybe the next one will as well. But I got a bigger issue because there's a negative inside my square root.
Pull out the I.
So we get a 3i, and I've got this 96 here, and
16 times 6.
good, 16 times 6. So out of the 16, pull out a
4.
times the 3i I already had.
So 12i times square root of 6.
There we go. So I've got a 2i squared to 6 plus 12i squared to 6 gives
14i times square root of 6.
14i times the square root of 6. We're just adding similar radicals together. Questions on this? Got a feel for what we're doing working with the radicals. We just pull out i's first, and it's a lot like section 1.8. Questions? All right, at your seats, I want you to simplify these. The square root of negative 4 plus the square root of negative 49. 2 times the square root of negative 4 plus 3 times the square root of negative 1. Square root of negative 16 minus 3 times the square root of negative 9. 5 times the square root of negative 18 minus the square root of negative 72. At your seats. I've never heard of worm's eye view. I've heard of bird's eye view. Worm's eye view, that's great. Radicands view. Mr. Radesky gives us donuts and then he proceeds to insult our glasses and tell us to rip our eyes out and makes fun of us, calls me a worm. Alright, square root of -4, Brandon.
Oh, 2i.
2i plus square root of -49
7i.
gives us
9i.
9i. How many had that for the first one? Questions. Next one. Here we have 2 times the square root of -4. So the square root of -4 becomes, Maddie,
2,
times 2.
4,
And then here, of course, the square root of -1 is just times 3.
4,
So we get
7,
7i. How many had that for the second one? On the next one, square root of -16, Audrey.
I. Oh, 4i.
4i. And then the square root of -9
3i.
times the -3, -9i. So we get
-5i.
-5i. How many did that answer? Look at the next one. Genesis, here, it's not quite as easy as the last ones because I can't just take the square root of -18, but I can at least start by pulling out
2 negative
as an,
positive
it's the square root of a negative. It's imaginary. First thing I always do.
I.
Class,
Hold on.
pull out your eye. Okay, so what do I do first, Genesis? And so initially we have 5i square root of 18, right? If we want to break down there. Then we'll factor
3 and 8. No.
split up in 18.
9 and 2.
Because I can take the square root of 9 to get
3.
times the 5i
15.
times the square root of the
2.
2. All right, so it's kind of a progression. Go ahead and take the next one for me.
Positive 7. We'll take the square root of 72.
Well, what's the first thing you got to do? Pull out your eye. Okay, it is. It's right up there with moist. All right, pull out your eye. It's a moist eye. Anyway, pull out the eye. And then Genesis, we want to factor the 72. And how do we factor 72?
9 and 8.
We could do 9 and 8, but see this way, I've got a 2 right here. So I really want to have a 2 in the 72. Try dividing it by 2. And we'll go with 2 times 36. And that's a little quicker way, right? So you've already done the easy one, do the harder one. Take out the square root of 36.
6.
So this becomes,
6i. Times the square root of 2.
and don't forget your
Negative.
negative. So we really have 15i squared root of 2 minus 6i squared root of 2 gives us
9 times the square root. 9i times the square root.
9i times the square root of 2. How many had that for the last one? Okay, questions on that? Questions on that? All right, next section. Multiply. Because obviously subtraction is adding the inverse, so subtraction was lumped in here. So to multiply. Complex, or to multiply imaginary numbers. Step number 1. Pull out your eye. Step number 1, pull out your eye. Step number 2, multiply coefficients and radicands. Multiply coefficients and radicands, including i's. Including multiplying i's. That's what happened to the seraphim in the Bible. And step number 3, reduce. Step number 3, reduce. So to multiply imaginary numbers, pull out the i's first, which I told you already was the key. That's what always going to be the first step. Always pull out your eye first. But we don't have to look at the problems. So if we had the square root of -25 times the square root of -4, the first thing I should do, class, is pull out your eye. So this becomes I times the square root of 25 times I times the square root of 4, which of course we know will become 5i times 2i, which gives me
10i.
10i squared, but what is I squared?
Negative 1.
-1. So 10 times -1 becomes -10. And there's my answer there. So even though we're multiplying two imaginary numbers, we get a real product. Write this one down. 3 times the square root of -10 times 2 times the square root of -8. Obviously, if the imaginary numbers are just so obvious, well, that's 5i, that's 2i, by all means. Here, that's not the case. Here, well, let's just pull out the i's. And what will I have, Kendall?
3i times the square root of 10 times 2i times the square root of 8.
Now that we've pulled out the i's, let's multiply coefficients and radicands. When we multiply the coefficients, Kendall, we get?
6i squared.
And we multiply the radicands, we get the square root of?
80.
80. What square is in 80 that we could use to reduce anyone?
4.
There is a 4. Something better. Let's just go with the 4.
16.
Okay, I heard it, 16 and 5. Okay. Well, and to be honest, and the point I guess I make here is, if all you see is the 4, then take care of the 4. Maybe you'll see the other 4 later. But, do something at least instead of sitting there staring at it. So we take the square root of 16 class, which is
4
times the 6i squared
24 squared.
times the square root of the 5. One last thing, we want to simplify the I squared. I squared is?
Negative 1.
So we really end up with
Negative 24 times the square root of 5.
-24 times the square root of 5. If you don't pull out your i's first, you would end up with 6 times the square root of positive 80. And you'd end up with 24 times the square root of 5, which is not correct. It is a negative 24. So we can't just say, well, multiply negative times negative to get positive. No, pull out your i's. I times I is I squared, which in the end will become a -1. Questions on this? So what if we had, for instance, the square root of -8 times the square root of 2? Michael, first thing I need to do
Take the I.
to get?
You get I times the square root of -8. Times
Well, it's not a negative anymore. I pulled the
Yeah,
negative out. It
times the
became my
square root
I.
of 8. Yeah. Times the square root of 2.
And that becomes, when we multiply the coefficients,
I times the square
And the
root
radical.
of 16.
and of course, square root of 16 is?
4.
There you go again. So we end up with
4i.
4i. Again, always Michael. There's tension after class. All right, questions on this. We got the feeling of what we're doing here. All right, so write this one down. The square root of -3 times the square root of -27. Square root of -6 times the square root of -24. Square root of -10 times the square root of 5. And then 2 times the square root of -8 times 5 times the square root of -3. Hang in there, Genesis. I don't pick on you very much, so you gotta have your turn every now and then, right? Besides, dry eye is a serious condition. When you dry eye, you want anyway. All right, check your work on the first one. Did you pull out your i's? Get I squared times the square root of 81 becomes 9i squared, or 9 times -1, -9. How many had -9 for the first one? On the next one, same thing. Pull out your i's, multiply the i's to get I squared. You squared 144, that's 12i squared, or 12 times -1, -12. How many had -12 for the second one? On the next one, you can only pull out an I on the first one, so it ends up being I times the square root of 50, 25 times 2, 5i, times the square root of 2 on the third question.
I got I times the square root of 50. I
Forgot to reduce the 50, okay, or the square root of 50 rather. Here, 2i squared of 8 times 5i squared of 3 when you pull out your i's. 10i squared square root of 24, that's a 10 times a -1. If factored 4 times 6, pulled out a 2, so that gives -20 times the square root of 6. I already had that for the last one. All right, questions at all on this? You left it as -10 squared root of 24?
No, I forgot to multiply the i's, so I got...
Oh, you just had a single I. Okay, make sure we multiply the i's as well. Next thing in your notes, to divide imaginary numbers. To divide imaginary numbers. Pull out your I, divide the coefficients and radicands including i's, and reduce. Or you could just say ditto. With everything we were just doing. We're just going to divide now. Otherwise, pretty much the same thing. So, divide the square root of -18, divided by the square root of -3. First thing I've got to do, class. Pull out your i's to get I square root of 18, divided by I times the square root of 3. Now, here's the thing. We're going to divide the coefficients. What is I divided by I? 1. Anything divided by itself is 1, or we could say the i's cancel. We cross them out. They're cross i's. And here the square root of 18 divided by square root of 3 gives, and there we go. And there's our answer. If we had the square root of -27 divided by the square root of -3, the first thing I got to do, pull out your I square root of 27 divided by I square root of 3. What happens to the i's? Cancel the square root of 27 divided by square root of 3? Square root of 9. But just 3. Notice when you divide two imaginary numbers, it'll always give you a real value because the i's will always cancel. What if we had 15 times the square root of -10 divided by 5 times the square root of 2? Well, here in the numerator class, I've got to pull out my I, but there isn't an I in the denominator, so it becomes 15I squared of 10 all over 5 times the square root of 2. So this time, 15I divided by 5, 3I, the square root of 10 divided by the square root of 2. And because I divided imaginary by real, I'm left with imaginary. Questions on dividing imaginary numbers. Feel like you got the idea? As long as you pull out the I first, you're going to be okay. Okay, so pull out the I and then do what you already know to do with the radicals from there. Homework for the weekend is to do pages 104 to 105. Pages 104 to 105. Practice 1 through 4. Pages 104 to 105. Practice 1 through 4 and 21 through 26. Practice 1 through 4 and 21 through 26. Also on page 111, do the review 1 through 6. Page 111, the review 1 through 6. One more time, pages 104 to 105, practice 1 through 4 and 21 through 26. And on page 111, do the review 1 through 6. We'll talk more next week about imaginary numbers and those complex numbers that I kind of previewed a moment ago. More in our lesson next week. Have a wonderful rest of your day. Have a wonderful weekend. You are dismissed.